right now.
No. All right, folks. We're going to go ahead and talk about our last couple of definitions up at the top here. First, global versus local minimum and maximum. I actually want you to change this. Global and local are two words we can use to describe it. I prefer absolute and relative. They mean the same thing, but these are two ways that we can classify maximum and minimum points. Now we're going to go back to quadratics for a moment. Bloop. Here's a quadratic. Here's another quadratic. Now, does it look like this quadratic has a high point? Yep. So this has a maximum, whereas this one has a minimum. So maximums are kind of like peaks or mountaintops. Minimums are like valleys. So the very bottom of it, the very top of it. Now, global means over the entire function. Local, maximum of an area, but not over the entire function. So, absolute, I want you to write reigns supreme. No other point gets higher or lower than that point. Local or relative, it's just comparatively high or low based on the surrounding points. So it's kind of the difference between a global celebrity and a local celebrity. Our News 9 guy is probably, a local celebrity. I don't know his name. I don't watch the news. But, we've got local people who are important in our community, but that is just relative to the other people in our area. Global is more absolute compared to everything else on the function. Last definition, last vocab thing is a turning point. And instead of this definition of any place where the graph curves, I want you to write that a turning point simply occurs at a maximum or minimum. All max and mins are turning points. And the maximum number of turning points is the degree minus 1. I would highlight that. The maximum number of turning points is the degree minus 1. So for example, if the degree is 5, the hole punch took that out. If the degree is 5, the graph could have at most 4 turning points. Could it have 3 turning points? Yeah. 2? Yeah. 1? Yeah. 0? No. It's got to have 1 turning point where it stops increasing and starts decreasing. Well, actually, odd degree functions can have 0 turning points. So folks, if you're like, I don't think I'll ever remember that, it's honestly hard for my pre-calc students as well to remember the turning point correlation. Here's what I recommend doing. We're going to take a look at an odd degree function where that's my end behavior, doing the disco. And we're going to see if I can draw 6 turning points. Should I be able to? Well, let's find out. So I'm saying this is degree 5. And I'm going to see if I can draw 5 turning points or 6 turning points. So let's go ahead and see what happens here. Actually, yeah, we'll just go ahead and try to draw 5. So I start along. There's 1 turning point. Here's another turning point. Here's another turning point. So far I have 3. Now this says I can have at most 4. Folks, what happens if I change direction and try to come back down to make a 5th one? What's my end behavior going to be doing? Then it's going to look like even end behavior. So I can't do this. I can't make that 5th turning point because that would change my end behavior direction arrow. So this has got to be curving up. That's why the most that I could have is 4. The most is 1 less than the degree. So how many turning points does a quadratic have?
4.
1. So the degree of a quadratic is 2, and the number of turning points is 1. And the turning point is where it stops going up and starts going down, or it stops going down and it starts going up. It's where it changes direction, which will always be at a maximum or minimum point. All right, folks, let's take it to the graphs. We've got this graph. Does it have some turning points? How many? 1, 2, 3, 4, 5. So 5 TPs, turning points. So could the degree be 6?
Yes. No.
Yeah. Could it be 7?
No.
Why?
One odd number.
Because that's odd, and this is even degree. But could it be 8?
Yeah.
Yep, so it could be either of these. It could be 10, it could be 20, it could be 500.
Could it be 1,000?
Yes.
No, I'm not.
But could it be 4? No, the degree can't be 4 because at most a degree 4 could have 3. So your degree needs to be large enough to contain all the turning points. It can't be less. So put not 4 though.
Or 2.
Or 2. So 4, not 4, nor 2. So that's pretty cool because we are just looking at the graph. We don't know anything about this equation, but we do know some possibilities for the degree, for the leading coefficient, and what we can find is that our x-intercepts can actually lead us pretty darn close to our equation for that polynomial. So folks, what about this one? How many turning points do we have?
1, 2.
2 turning points. So my degree could be 3. It could be 5. Could it be 1? No, because that would be a line. Should a line have any turning points? No. Alrighty, folks. So let's go ahead and describe these turning points. Now, it says global and local and relative. Go ahead and just cross those off. I find it helpful to instead just label what each one is. So we're going to start with just maximums. Do I have any maximums on this graph? Do I have any high points? Yep. This one at -1, 1. And this one at 2, 1. Now, are these going to be absolute or relative maximums? Absolute?
No. Relative.
Relative. So, folks, remember, the maximum, if it's absolute, reigns supreme. Are these the absolute highest points that I can get on my graph? No, because over here we keep going up, 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 and up, up, up without bound. There is no global, supreme, absolute high point because my graph just keeps getting larger and larger and larger. So there are no global maximums. That means this one's relative and this one's a relative. So relative max, relative max. How many minimums do I have on my graph? 3. Min, min, min. Now those coordinates are backwards 3, down 1. Forward 0.5-ish, down 1. And then 3, -1. Now, are any of these global or absolute? do these points reign supreme as the lowest points of the graph? Are we going to get lower than those points anywhere? No.
Yes.
Yeah. So those points are all global or absolute maximums. Absolute. So all absolute. You could say that it's got an absolute min of -1. That's more something that we use to describe in pre-calc. For us in Algebra 2, we're fine with just stating the locations of that absolute minimum value. So all of those are absolute. So are any of them relative? Nope. So no relative minimums for those ones. All absolute. Let's go ahead and look at our next one. I'll leave this up here for a moment. Folks, I want you to look at the maximums of this graph first. See if you can classify it as absolute or relative.
How do you find out the y-intercept? Like the exact.
We're just guessing it from the graph. We'll be able to find it exactly once we start looking at the equations. But for right now, we're just eyeballing it from the graph. So, does this graph have any maximums? Yep. It's got a little hilltop there, a little peak value. Is that maximum going to be relative or absolute? Relative. It doesn't reign supreme because, check it out, this side just keeps getting larger, larger, larger. So this is a relative max at the point 0, 3.2-ish. Good stuff. And then our minimum, do we have one?
No.
We do have a low point. It's low compared to all the other points directly by it. Is this relative or absolute? Relative. So we've got a relative min at -2, -1.2. All right, folks. How are we doing so far? Let's see if we can start putting this all together in the guided practice. Take out that blue packet. We're going to do a few of these together before I give you some work time. All right. So for each graph, describe the end behavior, the degree, the leading coefficient, the number of real zeros, y-intercepts, and any max and min values, making sure we classify them as either relative or absolute. So let's start with our end behavior. See if you can write that skeletal end behavior without looking back at your notes. Oh, weird. I thought I threw this one away. Where did you find it?
In the tray.
In the tray. Okay. Noted. Thank you. All right, folks. As x goes towards -infinity, f of x is approaching something. And as x goes towards positive infinity, f of x is approaching something. Folks, what are both sides of the end behavior approaching? Did you guys throw it?
No.
Who threw that? So f of x approaches infinity, positive infinity, in both directions. the degree for this one? Our end behavior is going in the same direction, so will the degree be even or odd? Even. Our leading coefficient is coming from our right arrow, which is going up towards infinity, so it would be positive. We don't know the exact numeric value. All we know is that the sign is positive. How many real zeros does this have?
2.
Just 2. So 2 real zeros. The y-intercept, looks like it's about at 0, -1. And I want you to state it as a coordinate. Don't just say -1, because I do want to still kind of recalling that the y-intercept is 0 and a number, whereas those x-intercepts are numbers and 0. Now, does it look like we have any maximums? Do we have any peaks? We do. This one right here is a peak. So at 0, -1. Is it a absolute max or relative max? It's relatively high. Compared to these other points, it's a high point. But compared to the graph as a whole, yep, it's definitely getting larger on those left and right end behaviors. So relative maximum. And then we've got 2 minimums. And I should not have traced the graph on that. It looks like, we'll just round it. It looks like that's at -1, -3. Leave some space to describe it. And then our other one's at about 1, -3. Are those going to be absolute or relative? Absolute. These are the lowest points on my graph. Nowhere are we going to get lower than those points. So absolute for both of those. On your own, I want you to try number 2. All of it.
Pencil sharpener.
Right on top of the file cabinet. There's an electric one up there.
So it's the same one as on the top.
All right, folks, let's start with the skeletal notation for the end behavior. How'd we do? Got to have 1 going towards -infinity and 1 going towards positive infinity. So x-axis, -infinity, x-axis, positive infinity. So let's go in the negative direction. As x goes towards -infinity, what's my function doing? Going down towards -infinity. As we go towards positive infinity, what's my function doing? It's going to keep going up towards positive infinity. Asking, what are my arrows doing on the left and the right? What's the degree, everyone? Odd. So arrows are going in opposite directions. They're doing that old disco dance. So they are odd degree. Leading coefficient on this one. Positive. Our right arrow is going up. Positive leading coefficient. All right, careful. How many zeros or x-intercepts does this have? Just one. So there's my x-axis. We are only hitting in one spot. Our y-intercept is at 0, -2. Let's look at maximums. Does it look like we have any high points? Any little mountain tops? Yep, we got one right here at 0, -2. But is it the absolute highest point on the graph? Nope, because right arrow over here keeps going up, 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 up. So relative max. Then we've got a minimum value here at forward 2, down 1, 2, 3, 4. Is that absolute or relative? Relative, because the left side continues to go down, so it's not the lowest point, just a relatively low point. Folks, do you have any questions? I think I'm ready to turn you loose on some practice. So in your purple packet for today, you should be able to do numbers 1 through 4. I guess you can use these headings if you want, but global means the same thing as absolute. Local means the same thing as relative. You use this time to work.